Are we a media company or a technology company? Facebook and the New York Times are both asking themselves this question. Facebook originally intended to focus only on building technology, to be a neutral arbiter of information, and this has turned out to be impossible. The Facebook newsfeed is defined by algorithms that are only as neutral as the input data. Even if we could agree on a neutral dataset to build a neutral newsfeed, the algorithms that generate this newsfeed are not public, so we have no way to vet their neutrality. Facebook is such a powerful engine for distribution, it has allowed for the rise in the number of publishers who can get their voice heard. And as a result of this, large media companies have lost some market share because Facebook has replaced their distribution advantage. The New York Times has always been a media company, but the standards for media consumption have shot up. Millions of people produce content for free, and that content is distributed through high-quality experiences like Twitter, YouTube, Medium, and Facebook. And when a page takes too long to load on NewYorkTimes.com, it doesn't matter how good the reporting is. The user is going to navigate away before they read anything. Today, the New York Times has built out an experienced engineering team. In a previous episode, we reported how the Times uses Kafka to make its old content more accessible. In today's show, we talk about how the Times uses React and GraphQL to improve the performance and the developer experience of engineers who are building software at the New York Times. Scott Taylor and James Laurie are software engineers at the New York Times, and in this episode, they explain how the New York Times looks at technology. The user experience on New York Times rivals that of a platform company like Facebook, and this is, funny enough, assisted by technologies originally built at Facebook, React, Relay, and GraphQL. If you like this episode, we have done many other shows about React and GraphQL. In fact, back in the day, we did an entire week of shows about React. And you can find all of our old episodes by downloading the Software Engineering Daily app for iOS and for Android. In the other podcast players, you can only access the most recent 100 episodes, but in our app, you can download all 600 episodes. And you can also get recommendations based on what you've listened to so far, and we're working on some other very cool stuff. For example, if you listen to an episode about React, maybe we can recommend you some great content about React. So we're building a recommendation system. We're building a new way to consume content about software engineering. And these apps are open sourced at github.com/softwareengineeringdaily. If you're looking for an open source project to get involved with, we would love to get your help. Now let's get on with this episode. G2I is a talent platform built for engineers by engineers. React Native, React, and mobile. The developers on G2I have expertise in the best tools to build your applications. When I need engineers to help me out with my apps, G2I is the first place I go, especially when I'm building with React or React Native. Contract a G2I developer to help you on a short-term basis or hire a G2I developer full-time. And if you're looking to build cross-platform applications in React Native, definitely check out G2I. The G2I platform is a community of React Native, React, and mobile developers, and these engineers can become part of your team. If you're looking for developers to build your product, check out g2i.co. That's the letter G, the number 2, i.co. You can also send me an email, and I'll be happy to tell you more about my experience with G2I. Find your React Native, React, and mobile talent by going to g2i.co. And thanks to G2I for helping me ship my products, and thanks for becoming a sponsor of Software Engineering Daily. James Laurie and Scott Taylor are software engineers who work at the New York Times. Scott and James, welcome to Software Engineering Daily.
Thanks for having us.
Today we're going to talk about a refactoring that the New York Times went through, mostly on the front end. Let's start with just giving an outline for where we are media-wise and how the New York Times is changing. it's 2017. There are up-and-coming media companies like BuzzFeed. There are social media companies like Facebook and Twitter. There are podcasts and YouTube, and media is changing fast. But in this maelstrom of changing media, the New York Times is holding strong as a durable media institution. In fact, it's growing aggressively. But how is the New York Times changing internally? What's changing and what is staying the same?
Yeah, so what's interesting, and James is going to talk about some of our backend systems, but actually a lot is changing. Pretty much everything is changing internally. I work in a team called Web Frameworks. Web Frameworks was kind of a group that was assembled to lead a migration to whatever our new platform was going to be. That team's about 6 people. I work on a team with the stuff we're going to talk about today with Jeremy Gayed, who's one of our lead engineers, Olav Sundstrom, and then Matt DeLambo and Carrie Price help out in different areas for our front-end architecture. Yeah, so the Times traditionally, the Times had a website for a long time now, and we've done different migrations over the years, but I think this is one of the more massive ones, especially on the front end. The Times has traditionally been a PHP site, actually, for a lot of the pages our readers read. So like, the home page and an article page and some collections. We're doing a pretty radical shift right now to some other open source technologies like React and Node.js and GraphQL. And with that, a number of different GraphQL clients we've been looking at, like Relay and Apollo. At the same time, there's a lot of change happening. We're moving stuff from data centers to the cloud in a lot of instances. And then James can tell you a little bit more about how we're actually migrating how we publish data.
Yeah, and we actually had a show recently about that with I believe the director of engineering, Berg Svingen. He was talking about how Kafka is moving a lot of its heterogeneous data sources to Kafka to unify them. And people can go back and listen to that. James, do you have any perspective on how the New York Times front end has evolved since the company moved online? Because I believe it started moving online in the 90s, and I imagine there have been many evolutions and refactorings since that time. Do you have any perspective on that?
I do have a bit of perspective. I've been at the Times for about 6 years now. So they're currently working on the 6th iteration of the website. When I arrived, it was the 4th iteration, and there are actually still pages here and there that are driven by 3rd and 4th and 5th iterations of the website. So I think things are changing more rapidly now.
Are there any usability or performance issues that have come because of the engineering decisions of the past? Because this refactoring that you made with GraphQL and Relay and React, what were some of the problems and the performance issues that you were seeking to improve upon?
Well, I think there's always concerns around, are we doing enough to, as we add new features to the site and as the code bases evolve, keeping performance up, and also, what's our strategy for always maintaining accessibility? And, I'm pretty proud of the New York Times for actually, in our last iteration, taking a pause at one point and really focusing on accessibility in a lot of different ways. And we have some members.
What does that term mean, accessibility?
Accessibility means for, I guess, disabled persons or people that need assistance via, maybe a screen reader, for people who are visually impaired, people who can't use a mouse. Just basically meaning that for people who need to use assistive technology, there is a little bit of work you need to do to ensure that you're not just writing freewheeling HTML that doesn't support the proper attributes you need to make the site accessible.
Yep.
So we have people that regularly listen to the site with a screen reader, or make sure that as we're tabbing through, it makes sense for somebody who's not viewing the website just through sight. And I think what we kind of view, the way we build websites, I think in general, from company to company, and really in this era, there's a lot of focus on JavaScript and JavaScript frameworks. And I think there are some advantages we can get with that. I think, an ideal scenario is that we end up with what we call a single page app. So if I'm on the home page, I can quickly navigate to an article, and I don't have this paradigm of like loading the entire home page, then doing a full request for the entire article page, and doing a full request for an entire something else. And there's a weight to that, and there's also a way apps are designed to either fit that paradigm or fit the paradigm where things are more modular and things are a little more elastic in the way they move back and forth. And, we're still figuring out a lot of that stuff, but we really liked some of the reasons we're replatforming are for that reason. But another reason is the way we maintain our code internally, the way we write code internally, the way we build user interfaces internally. We've just been really excited about using React, and it's kind of already paying dividends for us to be part of that ecosystem and just the way we can move and the way we can modularize things. And we're also looking at the way we can share those things. So teams across the company, how do we take components? And, what happened before is that because the main website, was in PHP, a lot of it. And the thing is, too, the Times is not one monolithic code base. There's actually, maybe several code bases that deal with different paths on the site. One of the problems we had is we didn't have a lowest common denominator language we were all writing these apps in. And so it was very hard to share code across projects. And I think, around the building, just Node.js and React has become pretty popular for a lot of these front ends. So it's made it easier for us to plan for the future and say, if we build these components this way, with somebody down in the newsroom for a side project wants to use it, in their project, it's actually very easy to share the exact same code.
Yeah, we actually did a show recently with Netflix, and Netflix has a team entirely devoted to making it easy for engineers to spin up new front-end clients. And this makes sense because Netflix is on so many different surfaces. But you think of the Times is a media company as well. Theoretically, it should be on all of the same surfaces as Netflix. So, it makes sense that the Times would have the same desires to make it easy for any engineer at the Times who wants to spin up a new application, a new front end, to have a buffet of tools and components to reach for and build that new surface.
Yeah, definitely. And I think that's one of our charges as the web platforms team or web frameworks team is that we need to pick solutions that are portable, that will hopefully survive, the next migration, and hopefully make it easy that if somebody wants to build things wants to build a New York Times shaped thing, it's very easy to get started. And we actually have an open source project called Kit, KYT, which is available from the NY Times GitHub account. It makes it really easy to spin up what we call isomorphic JavaScript apps. So that's where you have to deal with the server and the client. I found it so useful. I actually use it in all of my side projects or hobbyist projects. I think it's one of the best ways to get started with any project with doing isomorphic rendering. But that's something that we're building the New York Times on as well. And so as we evolve it for the New York Times, we're also open sourcing that. And I think another huge component about this is the data, and that the switch to GraphQL is also going to democratize this a little bit more around the company. Because as we know in the past, if you have web service driven apps or websites, what ends up happening is your code base, you need to create an HTTP client, and then you need to connect to several different REST services a lot of the time. And with GraphQL, we kind of have one place to go to get data. And so I think the goal, the utopia I see in my mind is that this GraphQL becomes the one place, if you're going to build a New York Times app, you can possibly go and get all this data from.
Yeah. And
that's the stuff that James's team is thinking about too. It's really working on what does this API gateway look like for the Times? And how does...
So before we jump into that, I want to get into the nitty gritty of GraphQL and Relay and React, but let's just set the table a little bit more. James, as the engineering lead of this project, and particularly as somebody who's been there for 6 years, give me a description for how this project to refactor the front end got started and how it ended up being the focus of kind of a bigger team that's, I think, 6+ people. Was this a gradual process? Did it start with just one person, or was this a concerted process where, top-down management was like, all right, we're going to do this big refactoring and we're throwing a big team on it?
Well, I think it was a kind of a combination of those. So I started out working with the native applications, and I was involved in several of the projects of getting native applications going on BlackBerry and on Windows. And as Scott mentioned, you have 15 different REST APIs that you have to get those teams to integrate with, and it can definitely be painful. So we actually started our project for the Android and iOS teams. It wasn't GraphQL, but it ended up being sort of a similar idea where we could take the existing APIs and produce like templates of the data that they required for producing their front-end applications. So as we were doing this, the Web Frameworks team was also thinking about what they wanted to do next. And Olaf Sundstrom and I had several conversations about various demand-driven architectures, including GraphQL. We looked at Falkor from Netflix as well.
This episode of Software Engineering Daily is sponsored by Datadog, a cloud monitoring platform built by engineers for engineers. Datadog enables full-stack observability for modern applications. See across all of your servers, your containers, your apps, and your services in one place to monitor performance and make data-driven decisions. Datadog integrates seamlessly to gather metrics and events from more than 200 technologies, including cloud providers, databases, and web servers. With built-in dashboards, algorithmic alerts, and end-to-end request tracing, Datadog helps teams monitor every layer of their stack in one place. But don't take our word for it. Start a free trial today, and Datadog will send you a free t-shirt. Go to softwareengineeringdaily.com/Datadog to get started and get that free Datadog fluffy t-shirt. For listeners who don't know, Falkor, and this is so interesting, that Falkor was created independently of GraphQL almost at exactly the same time. Project looks extremely similar. Both of these projects, as I understand, you guys can correct me if I'm wrong, the functionality is essentially you set up a GraphQL server or a Falkor server, and from the front end, you can make requests that are all formatted the same way, and it looks basically like a JavaScript, like a JSON object without the, it's like a JSON object of like what you're requesting. Like you say, I want to request a user and the user ID and the user's preferences and the user's top 4 articles. And it looks like a very general query. And then it goes to a GraphQL server or a Falkor server, and that request gets made more specific. It gets processed on the Falkor server or the GraphQL server, and then it gets federated to all these different data sources that might have REST APIs associated with them. And what that gives you is it gives you this middleware that federates one simple request into a complex set of requests to get disparate data sources. And what was so interesting is that Facebook developed technology that does this very specific thing at the exact same time that Falkor developed that Netflix developed this technology and called it Falkor. And it's just funny that the New York Times had the same problem. You had the exact same problem as Facebook and Netflix. We have a bunch of disparate legacy and new data sources. Maybe it's Bigtable, maybe it's a S3, maybe it's a random API out there like Stripe or something. And you need to get data from all of these different sources. You want to get them on one single query. Am I describing the problem statement correctly?
Yep, that's pretty much it, I think.
Yeah.
There was another group, Datomic, that has also been looking at this problem. So yeah, it all kind of happened at the same time.
Yeah. Why is that so troublesome to have to request data from so many heterogeneous data sources?
Well, I think at the times, one of the things that we've struggled with is sort of having conventions around APIs. So part of the problem was that A certain group that was producing APIs would have a certain type of response format, and another group would have a different format and a different authentication mechanism. So it was even more important for us, I think, to figure out a way to make that all sane for someone who wants to get data from multiple sources.
Yeah. James, when I land on a page on the New York Times and there is a GraphQL query somewhere in that page request and page loading process, where is that GraphQL query? Where is it executing in the process of the page request and the page loading?
So Scott may be able to answer that better than I, but I know that there will be a request from the server where they produce the original HTML, so that will make a GraphQL request. And then the client may make several requests, certainly initially one to fill out perhaps the below the fold part of the page, another one potentially to fill in sort of user-specific data, whether it's username or, let's say, items in their reading list or that sort of thing.
Scott, you want to provide more color on that?
Sure. This is where that concept of isomorphism comes into play, is that there's actually different data requested. Not totally different, but it's the different strategy on the server and the client. And the reason is that we actually want to do a lot of caching on the server to where we can render a server response, let's say for the homepage or for an article, and we can actually have that served by Fastly, our CDN. So because of that, we can't have user-specific data on the server because we're not going to be passing cookies to a server on every request. We're actually going to hopefully serve most of that from the cache. So on the client, what happens is that there's different mechanisms for doing this within the clients themselves, whether it's Relay or Apollo. But we do have sort of client-only data. So when you go to it in your browser, then we're going to make what are essentially AJAX calls or fetch calls. That's all kind of abstracted away into these frameworks for more data. So like an actual user and their specific data if they're logged in. There's not a ton of user-specific data right now, but definitely around whether you're subscribed, how many articles you've read, what stuff you may have saved to your reading list, stuff like that. That's the stuff that's specific to a user.
So we're talking about GraphQL specifically right now, but there are other technologies that from the Facebook stack that you adopted. There's Relay and React, of course. Explain how these technologies fit together, Scott.
So what's nice, React is one of those things that you could just lace it into your app in a small way. Like you could have a PHP app that's using React kind of in the corner. But we're using React really as our rendering engine for the site. With that, there's a couple different ways you can associate GraphQL data. The two we've looked at really are Relay and Apollo. And Relay sort of decorates your React components to where if I have a component for an image and I know that I need the URL for it, the width and height, and perhaps some other crops if I want to do maybe responsive image rendering or something, I can specify in this decorator really just, and it's kind of like this very specific GraphQL notation. So it looks like a GraphQL, what they call fragments. And, GraphQL queries are really like queries and fragments. And then there's these things called mutations. We deal mostly with queries and fragments. And fragments are what get associated with a specific React component. But the idea is that by co-locating your React component with the data you're requesting, is that you're never overfetching the amount of data you need. And then as your app evolves, you can be sure you're not breaking it. So that the way these queries get assembled by these frameworks is that, as if I have a fragment for a React component that's including other React components, then I'm going to include like a reference to those fragments within the component I'm currently in. So the idea is that I think one of the problems that happens with REST APIs over time and over the years is that we never know when we can remove fields and we never know who's using them. I mean, there are ways to find out perhaps, but it's hard. And another problem we run into is that with our REST APIs, the canonical representation of an article is actually a lot of data. And the canonical representation of what might be an image or a video, because an image may have 25 different crops associated with it. And with REST, you're always getting all the data a lot of the time. And it's hard to really filter down to just the data you actually need. And so we would actually have some REST API responses that were close to 1 MB, especially if you're trying to request that on the client. That's a pretty big deal for making a user download that data, especially if it's on their phone. So with GraphQL and with these React components, as you're assembling your React sort of tree, like building blocks, you're also, these frameworks are also assembling what the total query will look like as you combine the components you're using. And you may end up with a query that gets a lot of data, but the data is actually like 15% of the size of your actual full response from REST. So that's something we really like. Apollo is very similar, but Apollo doesn't have as strict requirements around where you specify your data, and they allow you to actually specify your data in different files.
What is Apollo? Because I always hear Apollo, I know this is a technology that's developed at Meteor, and I always hear it associated with the GraphQL conversation. What does Apollo do?
So let me just give a quick overview of like where the state of kind of Relay and Apollo. And actually last week was GraphQL Summit in San Francisco, and I actually gave one of the keynote talks there. And Facebook developed Relay internally, and it was actually part of their routing framework. And by routing, when we talk about single page apps, it means kind of how you declaratively say, here's my app, and then within it are these routes, and the routes may nest from there. But what happens is if you click a link, you can kind of go from page to page, and only the parts that change in the middle will change, basically. Well, what Facebook did with Relay is they created a way to have routes and also specify your GraphQL queries on those routes. Facebook obviously learned a lot over time, and also with scaling their React footprint and scaling their GraphQL footprint, especially on things like React Native and their mobile apps, they realized they needed to make a lot of changes to make this scale for the future and to be fast. So Relay became what they call now Relay Classic, and Facebook released Relay Modern. And Relay Modern is kind of the next generation version of Relay. And we evaluated it a lot over the summer, but there are some key components missing from Relay Modern that's going to make it almost impossible for us to upgrade to it right now. So one of our number one requirement is isomorphism, meaning that I need to be able to render on the server and the client. That doesn't come out of the box with Relay Modern. With Relay Classic, there are some pieces in the ecosystem that fill those holes, but they don't exist yet for Relay Modern. So we're actually looking at moving to Apollo for our GraphQL client. And Apollo, which is associated with Meteor, but is still an open source project, Apollo does have all these ecosystem pieces filled out. There are some differences between the way Relay and Apollo work, but all the developers that work on this kind of full time are in contact with the Facebook people a lot, and they're very active in the GraphQL spec and the GraphQL space, and they're all kind of, in the same area. So what was kind of strange is that I assumed, because Facebook, conceived of GraphQL and conceived of Relay, that they were by default the frameworks you're supposed to be using. And when I was at GraphQL Summit, that was not the case. Apollo, it feels to me, and it felt like this to a lot of people that were there, that Apollo is kind of like the winner right now in the framework race.
Well, so let's help disambiguate for people what exactly a GraphQL client does, because we've explained. And by the way, we've done some other shows about GraphQL, so maybe listeners want to go check those episodes out. But for the sake of the listeners of this episode, we've talked about how I land on a page, and if we were on the New York Times 5 years ago, if we went to the NewYorkTimes.com, my page fires off requests to several different RESTful resources. It gets those RESTful resources back and has the client itself, your client device, your poor iPhone, has to figure out which of these resources it actually needs. It has to filter through all these giant RESTful requests that it made. The advantage of a GraphQL server is you make this one query to the GraphQL server, and the GraphQL server federates the requests to the different RESTful resources, and then it parses through, okay, which resources do I actually need to return to the client? You give it back to the iPhone, and this is much less burden on the iPhone itself. You've offloaded a lot of the demand for requests processing and filtering to that GraphQL server. Maybe I've glossed over some things, but
that's mostly right. I think like the GraphQL client, I think the easiest way to think about it, especially in the React space, is it is what binds the data to your React components. But GraphQL is a little more nebulous than that, because you can make GraphQL queries outside of a framework. You can make them only on the server. I think for the sake of Relay and Apollo, they're definitely meant to be front-end frameworks for hooking up your UI to your data. Well, because for instance, the PHP version of the site, a lot of that data fetching happened on the server. And then we had our client JS was kind of a bunch of different backbone modules that also requested data via Ajax, but it was very freewheeling, and it was hard to know like what they were getting where and where they were getting it from, because you might hit a user service, you might make a request for the navigation, you might make a request for infinite scroll for what we call collections, and those APIs may have been all different, generated in different places. Some need auth, some don't, some need cookies. It was hard to tell. What happens now is that because GraphQL is kind of the one clearinghouse for data, we may make GraphQL queries in several places in the UI or in response to user actions, but I feel like it's a much tighter integration with the data, and you actually have to think way less about the specifics about how you're getting the data and the specifics about what's resolving the data. It's really this one query language when you need data for your UI, and the rest is somewhat magical. But the other piece I wanted to say about GraphQL Summit is, and James can talk a little bit about this, is Facebook open sourced a reference implementation, like a node implementation for GraphQL server. But the trend I saw at GraphQL Summit was actually, there's a lot of big companies there, Twitter, Twitch, Coursera, Facebook, obviously, and like people are building GraphQL servers. There's a lot of open source projects in multiple languages. So if you use Python, there's Graphene. If you use Java, there's GraphQL Java. And then the implementation we use is Sangria. It's written in Scala. I was actually surprised that the Scala implementation seemed like the most popular among the presenters and the attendees at GraphQL Summit. And so James can maybe give you some background about why they picked that. But it was weird, though, because, it's been a year ago at GraphQL Summit. I wasn't there, but I talked to a lot of the attendees about it. When they asked who was using GraphQL, not a lot of people raised their hands. There was a lot of interest in it and a lot of curiosity. And now it's become very mainstream. Twitter is talking about here's how we use GraphQL, not if. There's a lot of different, IBM, there's a lot of these different companies that are like, yes, we're definitely using GraphQL. This makes so much sense, and here's how we're doing it.
James, so give a little bit more color on that. So you were saying that was the reference Facebook released a reference implementation for the GraphQL server?
Yeah, in Node, because there's two pieces. I mean, even if you're running a Node.js app, you're going to have two servers. One is your GraphQL server, and one is your, Express app that's running your application.
Right.
But at the times, we have like 300 engineers or so, and so we're going to have big teams and big problems. And so James is leading the data side of things, and they've been implementing our GraphQL stuff.
Yeah, so back to that decision point when we were looking at Falkor versus GraphQL, I think one of the big appealing things about GraphQL was that it was a spec. And yes, there was this reference implementation, but there were also lots of other implementations out there, including Sangria. And our project that was the previous iteration before GraphQL, it was already written in Scala, and it was using Twitter's Finagle framework, which I think fits in very well with this sort of federated data model. And it was actually pretty easy to just put Sangria in the middle of all that.
So what about the Scala implementation of the GraphQL server made it so popular? Why was Scala a good fit?
I'm not sure that specifically. I think at least from my perspective, one of the advantages is that Sangria allows you to construct your GraphQL schema in many different ways. So there's this sort of simple standard model of creating it via code, but there's also ways where you can take static schema files and then materialize your schema at runtime. You could have a schema per client if you so desired. It makes it very, very flexible.
I think too, like, Sangria being an open source project, a lot of the vibes I got at GraphQL Summit were just that, Oleg, the guy who leads the project, has built a lot of features for it. It's very active. A lot of people were just kind of very appreciative of like what he's already done with it. There's also this notion, I don't know how much you've heard about this, of schema stitching. So this is kind of a new, in the past 6 months or so, mainstream idea of like, if I'm IBM, my backend server system probably looks like an API gateway, but then does it look like one GraphQL server? Or is this GraphQL server actually federating schemas from across the company? And what does that look like? And how does the implementation work? So for the New York Times...
Meaning that there would be many people in the company who would express a GraphQL schema as the way to fetch data from their API?
Yeah, so the schema really, it comes down to these type definitions and like these resolvers. So if I want to get a recipe, how do I resolve the recipe from the New York Times, data universe? Right. And how does a recipe fit into an article about cooking that might want to include a recipe? So, James's team works with what we call our publishing pipeline, which is really, which is pumping out the New York Times as we know it, which is articles and, images and videos, and it's kind of like hundreds a day, and it's like huge over time. And how do we deal with that system? And there are other kind of side projects to where we have a games team. What if the games team wants to become part of this big kind of GraphQL clearinghouse for data? Is that something that James is going to do, or is that something that the games team could probably do? But then James team can provide a way to actually stitch that data into our main schema. And I think Sangria was actually hinting at this for a while about how do we actually take different GraphQL schemas and put them together. But the people around Apollo have released this concept of schema stitching to where you can actually get multiple remote schemas, and your GraphQL server can kind of be a proxy to all of them. And then there's kind of this configuration you add to link certain parts together. GraphQL Summit, one of the guys from IBM released this project called Gramps, like, GRAMPS. It does kind of a similar thing. You can pull in multiple schemas, and it acts as kind of like this gateway to those schemas. So we haven't figured that out yet, but this is the kind of thing where what conferences do for you is like, this sounded avant-garde to us, but when we were at the conference, a lot of these different companies were talking about it like, yes, we're going to figure this out. This is how we want to do things.
Vivid Cortex is the best way to improve your database performance, efficiency, and uptime. It's a cloud-hosted monitoring platform that eliminates your most critical visibility gap, providing insights at 1-second granularity into production database workload and query performance. It measures the execution and resource consumption of every statement and transaction, so you can proactively fix future database issues before they impact customers. To learn more, visit vividcortex.com/sedaily and find out why companies like GitHub, DigitalOcean, and Yelp all use Vivid Cortex to see deeper into their database performance. Learn more at vividcortex.com/sedaily and get started today with Vivid Cortex. So I want to give people a top-down view into this because we're touching on a lot of disparate ideas, and some people might be a little bit confused. So are you describing a world in which at the New York Times there's a bunch of different teams? There's maybe a team working on recipes and cooking information. There's a team that's working on games. There's a team that's working on old articles, maybe the back catalog of the New York Times. And you want to make it easy for a front-facing client to easily request data from all of these different sources and pull it together in a web page, a single web page. Maybe you've got a web page with a game and a recipe and something about the JFK assassination, so it's got to delve into the back catalog. You've got to make all these different disparate data sources happy. The front end request for all these data sources happy. And so you want each of those disparate data sources, the recipes team and the games team and the back catalog team, you want all of them to present a schema that the centralized GraphQL server can access. Am I painting the picture correctly? The schema idea?
That sounds good to me.
Okay.
I think like a more concrete example might be something like real estate. Some of these things aren't REST APIs. Some of these things might be protobufs. Some of these things might be RPC calls. Some of these things might be flat files. We don't know. But the idea is that if I'm a New York Times developer, wouldn't it be nice if I could sit down and start hacking on an app that just uses the New York Times wealth of data sources?
Right.
So why can't I, when I'm creating an article and I happen to know something about the location of the article, let's say it's in a certain neighborhood or it's in San Francisco, why can't I also show you real estate data in that same response, right? And right now, that's the stuff that's hard when you have disparate services, because how do I get the real estate data? Do I have to write a HTTP client for it? Is it JSON-P on the client? Is there authentication? And a lot of times what happens is that there's different authentication for every service. And so how do I manage that? How do I manage that on the client? It's just, there's a lot of different pieces to consider. So GraphQL is kind of this magical thing. The devil is in the details, and that's the stuff James's team is working on. Is, some of this data is kind of a one-to-one resolution where you may have a flat structure of, name value pairs. Those are pretty easy just to return. But what does it look like when one of those fields needs to resolve a different service that's not REST, that's something else? It's like that's where the magic of GraphQL kind of comes in.
So, James, when you're talking to the recipes team or the real estate team or the back catalog team, is the onus on them to present a way for the centralized GraphQL server to be able to access information from all of these different back-end data sources?
Well, I think it's a process, and we're certainly not at the point where we are stitching several GraphQL APIs together at this point. But yeah, it's a conversation between the producer of the data and the client to figure out what exactly that schema should look like and how that schema fits into the already existing schema that we have. If you take the back catalog example, these are articles that we're talking about, so we can probably just use the same article schema that we've already developed for articles that are currently being produced on the site.
So, Scott, you were talking earlier about the fact that you can't go to Relay Modern yet. So there's these different versions of Relay, and Relay again is the what's going to bind the response from the GraphQL server. So you have this GraphQL server that goes out and federates requests to all the different data sources, pulls them all together, returns it to the client, and is going to bind that data to your React components on the front end. And there's Relay Classic and Relay Modern. Relay Classic did the query parsing logic at runtime. Relay Modern puts the query parsing logic at build time. What's the difference between those, and why is the New York Times unable to take advantage of Relay Modern? I think actually you said you don't use either of these. You actually use Apollo.
Well, so that's what's interesting. I think you're referring to like my Medium post I made in the summer, where that was a lot about just kind of like restating our mission, just because what are we really trying to accomplish with this re-platform? At the time, Relay Modern either hadn't been released or was on the horizon, and we were going to try to move forward with it when we found the time. And I ended up doing a lot of side investigation. Like I wrote some projects using WordPress data instead of using the New York Times. Because one of the other challenging things is that, especially as a React app, we may have 400, 500 React components that all have these GraphQL decorations. And so if something needs to change across the board, it's very hard to try out new frameworks. So we'll typically try them out on a smaller scale on kind of an example project or a side project. And The thing about stuff that comes out of Facebook is that Facebook has a very specific, engineering system to where adding build time steps is not really a problem. So like Facebook's code has to be transpiled in 10 different ways, everything you do. So there's kind of a culture around these build steps. And that's not a huge problem for us, but if we're going to introduce this build step, it does add some complexity to our project. But the real reason that we couldn't move forward with Relay Modern is just the ecosystem around it. And I'll explain a little bit. So when you do routing, which means going from page to page in a React app, there are only a handful of choices that people tend to go to. One of those is React Router. And to make React Router work with Relay, there's a library called React Router Relay. But then to make it work on the server, and server rendering means that like when I go to the page, I see the whole page. And then the client may come in, and actually React may do a re-render on the client as well, but you won't notice. A client-only app typically means that you come to the site and there's a bunch of these loading graphics that make you think there's a lot of loading happening, and there is because we're making the request for the data. And so if we don't have a server render, if you were to view the source of the web page, there wouldn't be a web page there. And so we do need that and want that. So with Relay Modern, a lot of the libraries that were needed to make server rendering possible in Relay Classic just don't exist. And those projects don't have any plans to upgrade to Relay Modern. Relay Modern is wildly different than Relay Classic. Relay Classic did a lot of magic in the heat of things. So like when we say runtime, we're meaning as their app is running, it's doing a lot of this parsing logic. The problem with that Facebook discovered was that over time, as your apps get huge, that cost increases as well for the runtime parsing. And they realized that a lot of the stuff we're doing is statically knowable at build time. So you can actually do that parsing ahead of time, and your app can run and already have that parsing done when you're making your queries or parsing your fragments. Mm-hmm. So that idea still exists and it's great. But so the problem was that the tools to do isomorphic rendering, there was only one, and that project was very small and only had one maintainer. And it becomes the kind of thing where, do we want to pick a project that's for the New York Times for the future that has that little support, especially the community around it? Because we want to rely on open source when we can. And so when we looked at Apollo, we realized we can actually get the same thing from Apollo. However, we have a lot more documentation, a lot more community effort around it. It's really become the de facto open source library. And I thought when I went to GraphQL Summit, it might have been mixed, like half Relay, half Apollo. And when I gave my talk, I was actually one of the only people that talked deeply about Relay. A lot of people didn't even mention it. It was just Apollo kind of became the de facto standard. So we realized that going from Relay Classic to Apollo wasn't actually that huge of a lift. And then the Apollo has a lot of plug and play pieces to where you have a lot more options for how you do things or how you customize things. And lastly, like if I have somebody on my team and I really want them to get some Apollo knowledge, I can point them at a lot of documentation. Relay has some documentation, but it's an elegant framework, but it's also extremely complicated. And so I think we were kind of afraid that a small number of people in the building would really understand Relay, and they become single points of failure for this information for this architecture.
Yeah. Very interesting. Okay, let's take a step back. I want to understand more about how engineering works at the New York Times. As you know, I know we're up against time, but we did, like I said, we did the show with Berge Svingen about Kafka at the New York Times, and that gave some insight into how the legacy of different data sources at the New York Times created some different engineering challenges, but it created a hotbed of interesting engineering solutions as well. James, since you've been at the New York Times for a while, can you talk about the interaction between the back end and the front end engineering teams, or just the different engineering teams, the different technical teams at the New York Times?
Sure. I think for a long time, the New York Times, there was definitely silos that popped up, fiefdoms. People were developing a certain way, and they wouldn't really talk to other teams that were doing similar things. And the whole time that I've been there, that's been a big challenge to try to get communication happening throughout the entire engineering team. I think we're in a much better place now than we were. We have a whole RFC process where every team is expected to share with everyone else changes, new architecture that they're introducing. We still don't have, I would say, standards around languages to write in or frameworks to use, but we're slowly getting there.
And what's been your perspective on the interaction between engineering and the journalism team?
So the teams that I've been involved with have largely not been interacting with the journalism. We have a specific group that does interactive news, and I know they're very much embedded with the journalists and producing the sort of presentation of the stories alongside the people who are writing the stories.
It was about 4 years ago, the Times did this innovation report too. If people don't remember that, I think we've been slowly moving closer to the journalists in a lot of ways, and the journalists are moving faster kind of away from print and more towards the web first, which sounds strange to us because we're all engineers and we've lived in the web for a long time. But I think journalism, especially the New York Times, used to mainly be a printed paper that people got on their doorstep, and it used to, a lot of the revenue came from print advertising. And so this huge paradigm shift, there's a lot of people who may have worked at the Times 30, 40 years, and then all of a sudden here we come with React and GraphQL and stuff, and they're like, what's going on? So I think there's definitely always been a newsroom presence with technology. We have a graphics team that's insanely talented, and a lot of cool projects have come out of the graphics team. Jeremy Ashkenaz was a member for a long time, and Underscore and Backbone and CoffeeScript were written by him and perhaps others. Michael Bostock, who was the author of D3, was on the graphics team, and I think Rich Harris is there now, who's the author of the Svelte framework. And a lot of those developers are journalists / developers, which is neat. So a lot of our graphics team, which does produce a lot of these interactive pieces, they're also the journalists on a lot of these stories. Yeah, I think there definitely was a divide for a long time, especially with technology, around the business and then the newsroom. And I think that those lines are getting blurred a lot now to where we're all kind of one ecosystem again.
Yeah, no, that's certainly what I'm seeing. Okay, given your vantage point at the New York Times, I want each of you to tell me something that I might not know about where media is going, or what you're seeing at the New York Times that might surprise me. As somebody else who is in media, but I'm at a much smaller media company, Software Engineering Daily. What's something that might surprise me about how things work at a large media organization that will give me some perspective on where the media landscape is going?
It's always changing, and I think that before I came to the Times, I think close to 5 years ago. I thought the Times was going to be this gold standard for technology, and it was going to be on this level that I had never seen. And in a lot of ways, the Times is just a traditional big company with the same problems every other company has. But what's inspiring me is that our technology team now has, in addition to a video team, there's an audio team, there's a 360 video team, there is a VR team. What can be exciting about that is that as we're looking at these technologies like React, it's how does React Native fit into these things, and how do we actually work across these teams to create new journalistic experiences? I think right now too, there's kind of this arms race that I'm seeing, even from as an outside perspective sometimes, is companies like the Washington Post and the New York Times, which are becoming so crucial in this political environment, and just kind of this new universe that we're living in. There's a lot of enthusiasm for these institutions, and there's a lot of support, and our subscribers support us monetarily, and it's it gives us the freedom to experiment more and kind of delight our readers more. And I think that one of our main focuses as a company is how do we really engage these subscribers and give them the experience that's worth paying for. And so because of that, I think you're going to see a lot of experimentation here, the Washington Post, Los Angeles Times, elsewhere. So, I mean, for me personally, it's actually a very exciting place to be. But, when you go to these conferences, we're all solving the same problems. We're all trying to figure out what this new universe is. And with software, React has kind of been the hot thing for a couple of years now. Like we're all these big companies though are trying to figure out what does it mean to be an enterprise grade React app, and how does that scale with software, and how does that scale organizationally? And I think this GraphQL piece is a big part of that too.
James, anything you want to add?
I just want to add that alongside all the new types of ways of telling stories, so the consistent thread for us from the data perspective is how do we capture that in a way that will make sense in the future. I mean, we have 150 years worth of archives, and what is that going to look like in another 50, 100 years?
Definitely. Well, that was one of the challenges that Berge was talking about in my interview with him. So it sounds like a great place to close. Well, James and Scott, thank you for coming on Software Engineering Daily. It's been great talking to you about GraphQL, and I've been enjoying the Times' long-form journalism for a long time. So thank you for putting your legwork into making that institution tick.
Yeah, thank you so much for having us.
Yeah, thank you.
Are you a Java developer, a full-stack engineer, a product manager, or a data analyst? If so, maybe you'd be a good fit at TransferWise. TransferWise makes it cheaper and easier to send money to other countries. It's a simple mission, but since it's about saving people their hard-earned money, it's important. TransferWise is looking for engineers to join their team. Check out transferwise.com/jobs to see their openings. We've reported on TransferWise in past episodes, and I love the company because they make international payments more efficient. Last year, TransferWise's VP of Engineering, Harsh Sinha, came on Software Engineering Daily to discuss how TransferWise works, and it was a fascinating discussion. Every month, customers send about $1 billion in 45 currencies to 64 countries on TransferWise. And along the way, there are many engineering challenges, so there's plenty of opportunity for engineers to make their mark. TransferWise is built by self-sufficient, autonomous teams, and each team picks the problems that they want to solve. There's no micromanagement, no one telling you what to do. You can find an autonomous, challenging, rewarding job by going to transferwise.com/jobs. TransferWise has several open roles in engineering and has offices in London, New York, Tampa, Tallinn, Cherkasy, Budapest, and Singapore, among other places. Find out more at transferwise.com/jobs. Thanks to TransferWise for being a new sponsor of Software Engineering Daily, and you can check it out by going to transferwise.com/jobs.
Wow!